It's a pleasure to be here. I appreciate your taking the time to spend a few minutes. I will explore a little bit of my personal experience with this as we go along. Here's my revelations about my participation. I've been fortunate to work with a liposomal encapsulation of glutathione for the last 5 years, and it's really taught me a lot about biochemistry in general and glutathione specifically. I'll show you some of the characteristics of this material that have been published, and I'll share with you some of my some unpublished data also. The focus of the talk is on the antioxidant, anti-atherogenic properties of glutathione, but specifically related to the liposomal form that I've been working with, because it turns out to have some characteristics that make it quite ideal for research in basic science. As far as glutathione and why you need to know about it, I thought it would be appropriate at the anti-aging conference to point out that as we get older, glutathione becomes depleted. It's one of the few things in the body that actually you can measure decrease as we get older. As it turns out, in a group of women who were in excellent general health on up from their 60s to 100 years, they had a high level of glutathione compared to their peers. So some people define aging more in the category of being functional as we get older, and avoiding age-related diseases such as atherosclerosis should be a critical concern for all of us. There's still a controversy about oxidation stress and the role that it causes in creating disease. Some people, in aging particularly, and some people contend that getting older you become oxidized. Other people contend that oxidation speeds aging. So you'll see some data today about the mechanisms of disease and perhaps draw your own conclusions. Nonetheless, as early as 1992, the role of glutathione in aging has been published, and the real key is in the removal of toxins, which all of us are exposed to in the modern world. I get going and forget where I am in time. I'm pretty sure I'll be okay in space here because I'll be in front of you folks, but just so I know where I am time-wise, I'll start this. It also is a tremendous component of maintaining immune function and avoiding inflammation. We're going to talk about that, but as we go along, if you want to know more about inflammation, there are a few articles that I can direct your way if you contact me after, which show that depletion of glutathione increases the cytokine production towards inflammation. As far as low glutathione and heart disease, there's two well-done studies. One showing in apparently healthy adults that if their glutathione is low, the likelihood of their progressing to coronary artery disease is significantly elevated, and it correlates with the increase in the ratio between reduced glutathione and oxidized glutathione, and we'll talk about that a little more. There's your reduced glutathione and your oxidized. And then another study about a year later showed that people that had a coronary ischemia and required a reperfusion procedure, that their incidence of severe events within the next 18 months correlated directly with the amount of reduced glutathione that they had measurable in their bloodstream. Now, I'm going to contend as we go along that the amount of glutathione in your bloodstream is ironically may not be the ideal marker, because by the time it becomes deficient in your bloodstream, there's going to be tissues that have been robbed of glutathione to allow the body to maintain it in the bloodstream. If you don't, your red blood cells can become damaged, and you'll develop a rapid hemolytic anemia, potentially, or ahemolytic anemia. And so the blood level of glutathione, while it would be nice to have a marker, I'll show you towards the end, but there may be some other markers that might be useful to monitor what's going on. So why do you need glutathione? Well, in the production of energy in the mitochondria, the production of free radicals and reactive oxygen species are an inevitable response to the production of energy. As you make ATP, you produce oxygen radicals that cause oxidative stress. And as you're talking about your membranes, your polyunsaturated membranes are very vulnerable to oxidative stress. And once these membranes become altered, they cannot easily go back to normal. They have to be recycled. And part of the reason we have LDL is LDL carries free cholesterol. It's a complex, as you'll see. It carries new, fresh, theoretically, free cholesterol to replace the damaged cholesterol in the lining of membranes, both in the cell, outside, and also the internal structures of the cell, like the nucleus and the mitochondria. So when you get an alteration in the cell membrane inside the body, you don't have a good visualization of it. But here's a nice membrane on an old steel ship that's become oxidized from sitting in the salt and oxygen environment, water environment, and you see that this membrane starts to break down. Same thing happens in the body. When you alter the structure, you alter the function of these membranes, and they become less efficient. And that's theorized as part of the reason, it's part of the problems related to the intake of minerals as well as insulin function and that sort of thing as membranes become oxidized. So the body has a series of antioxidants to prevent the oxidation. We all know about vitamin C and vitamin E and the polyphenols, and there are other antioxidants, of course. Glutathione has a particularly special role. It's basically 3 amino acids, with the cysteine carrying a sulfur molecule that is responsible for its function. Well, why don't we just take a lot of cysteine, which is a building block and can, over time, raise glutathione. It turns out that the combination in the glutathione structure allows it to work with enzymes, and that's the unique part about glutathione. It's the active substrate for a number of enzymes. Glutathione transferase is one we're not going to talk about today, but that I call the matchmaker enzyme. It introduces glutathione to toxins, and if you're low in one of the isoforms of GST, you have an increased risk of accumulating toxins. The one we are going to talk about is the one that takes care of the hydroxyl radical called glutathione peroxidase. If inside the mitochondria you form superoxide as part of the production of energy, this can, with SOD, which is an enzyme we consider an antioxidant, form hydrogen peroxide. But in the presence of metals, this will go on to form the hydroxyl radical. Now, the hydroxyl radical has a really strong pull for an electron and a proton. It wants to go back to water. And it'll pull this off of any available structure, whether it's a protein or a lipid and that sort of thing. And that's where a lot of the destructive experience comes from with free radical production. Nitric oxide turns out to be made in the mitochondria also, and in the presence of superoxide, this will go rapidly to peroxynitrate. So you go from no to, oh no, that's peroxynitrate, thank you, yeah. So in inflammation, the polymorphic nuclear cells will produce myeloperoxidase that will change this hydrogen peroxide that can diffuse not only out of the mitochondria but out of the cell and become hypochlorous acid. That's bleach. Well, these are all used in defense of the cell, and glutathione, either directly or indirectly, takes care of each one of these free radicals. So you get an idea of how important and how much use there is for glutathione.